The bell rings. A voice overhead screams out, "Structure fire, 1234 Main Street." Men and women all across the world run for gear strategically laid out in bays and jump on apparatus. As apparatus scream out of bays with sirens wailing and lights aglow, they will come up on a scene of a house or a structure with fire blowing out of every window. As they pull hoses and get to the front door or get to the strategic points, the nozzleman will yell, "I'm ready for water." This scenario happens all across the world many times a day and night. My name is Brett Grant, and I drive and operate an engine that responds to these type scenarios daily. This was going to be a dynamic evolution, but since it's 19 degrees, we didn't want to spray water. We're doing this from the luxury of my house. With the help of my children's Legos, we will demonstrate a few things. We're gonna talk about today. We're gonna talk about where does the term plug come from, because that's a term commonly used. Where does the water out of the hydrant come from? How to get water from the hydrant to the engine, and how does it get from the engine to the building? In the past, you've seen it many times, whether it's in a children's story about firefighting bears, a dramatic prop used in a movie of a car chase that runs into a hydrant with water spraying in the air, or on the news of children playing in the streets under the spray. The use of hydrants has taken many shapes, but its original purpose is still in use today. The term plug can be traced back to at least the 17th century. In those days, logs were used and cored out with a 4-inch bit. As you can see here, the end of the log has been drilled out about 4 inches. And then these logs were buried along the streets. When a fire occurred, firemen would have to dig down to find the logs. Once unearthed, water would be pumped down into these logs, and the firemen would drill into the log at the closest point to the fire. Once the hole was made and water was available, the men could set up either a bucket brigade or pump from the hole to their apparatus. Once the fire was out and no more water was needed, they would stick a plug into the hole. Next, they would mark the street where the plug was for future use if needed. Today, the term we use in the fire service is a hydrant. The invention of the post or pillar type hydrant is generally credited to Frederick Graff Sr. He was the chief engineer of the Philadelphia Waterworks in 1801. The first cast iron hydrant was produced by cannon makers Foxwell and Richards in 1803. So, now that we have a little understanding of the terms, how does the water get to the hydrant for us to use? Well, here we go. Just like the pipes that bring water to and from your house, municipal water is set up the same way. It's set up on a grid system. So, with the help of my son's Lego Streets, you can see where the line breaks are in the street. It's kind of like a grid. Well, houses and neighborhoods that sit on these grids, this is how the water is supplied. So, pipes underneath the ground are usually 6 to 12 inches in diameter, depending on if it's residential or commercial. The water in the pipe can come from usually 1 of 2 places. It's rainwater that's stored either in wastewater treatment facilities and pumped to the tower, water tower, if you will, or sometimes they come from underground cisterns, which are natural formed spaces or negative spaces in the ground that hold water. They can be pumped from, kind of like drilling for oil. You get water. So kind of now that you have a general idea of how water is delivered from wastewater or towers to your houses, we can move on to hydrants. So for this little evolution, like I said, it was going to be outside, but it's a little cold outside, and didn't want to spray water and freeze the ground. So what we're going to do is, I have a fire engine. Actually, it's a truck that will lay into the hydrant, and we will get water to the house. So if you will follow me, we'll take water from the wastewater facility to the hydrant, to the engine, to the house. So as you can see, we have a structure fire. we have our truck company coming down. Okay. Obviously by NFPA codes, we don't ride on the sides and we do our seatbelt to the end. So what we'll do is the first man will, or the driver will stop. Okay. The hydrant guy will get off. He will get his tools and a radio, and he will pull hose. Normally, if the hydrant is farther away, they will drop him off at the hydrant. He'll pull his hose. Okay. Attach to the hydrant and give the driver either a wave or call on the radio saying that he can proceed. The driver will take the apparatus down and park where he so desires. He will then exit, and then he will hook up his end of the hose to his apparatus. This hose that comes off the hydrant is normally 5-inch. We call it LDH, or large diameter hose. It's normally 5 inches. It's made of a thick rubber material, and there's positive pressure that comes from the hydrant. So once the driver is ready for water, he will call back to the hydrant man and say, we're ready for water. Or some departments will give short blasts from the air horn. It's for the department I work for, we just call on the radio, or we use hand signals. So, using his wrench, hydrant wrench, the hydrant man will open the valve on the hydrant, and water will pass through the 5-inch into the apparatus. You have a nozzle man who can spray water from the ground, or since we have an aerial with water, we can spray from the air. Now, once we have water into the engine, the water will enter at a certain PSI. That's your intake pressure. We have a pump inside the engine that will speed the water up. It runs through a centrifugal pump and basically boosts the PSI, so which is your discharge pressure, to whichever appliance that the driver or the structure calls for. The department I work for, we have basically 3 different discharges. We have an 1 3/4 for our pre-connects that we pull that are already plumbed and connected to the engine. We have 2.5, which are also connected, and we have a 4-inch, which we can take a large diameter hose and supply an engine that's further from the plug. So there we have the different ways of taking water and showing you how water goes from the water treatment plant or the tower through the grid system to the hydrant, which comes to the engine, which is applied to the structure. Thank you.